So in this problem, we have a square root in the equation and not a square. All right, so again, in these equations, we need to do the opposite. So the opposite of a square root is going to be a square. So I need to square both sides. And if I do square root of x times the square root of x, if you remember your radicals, you end up having the square root of x squared, because you multiply what's underneath the radicals together, and the square root of x squared was just x. And when you squared the 7 times 7 equals 49. So now we have x equals 49. Now, before we said, with the square you had two answers, but here you only have one. We can take the square root of 49, that gives you 7, but we can't take the square root of negative 49, okay, because we said 7 times 7 equals 49, but negative 7 times negative 7 doesn't give you negative 49, it gives you positive 49. So in this case, if you deal with imaginary numbers, you end up getting 7i, but that's not the same as 7. So in this one, you only have one answer, x equals 49. If you take the square root of 49, that gives you 7. So again, we have a square root in here, but we need to get the square root term by itself, the square root by itself. And now we have 5 times the square root of x equals 20. So that's multiplication, so I gotta do the opposite, I gotta divide both sides by 5. Okay, that reduces down to 1. 1 square root of x, or just square root of x. 20 divided by 5 is 4. Okay. And again, when we have a square root, we need to do the opposite, so we're going to square both sides. When you have the square root of x squared, that's just going to be x. And 4 squared, 4 times 4 is 16. So here we have x equals 16. So if I have 5 as the square root of 16, square root of 16 becomes 4, and you get 5 times 4, and that gives you 20. Okay, so both sides will equal 20.